Good morning to all. Yesterday we explained about the methods which express the concentration of solution, the different methods, and we did some problems based on ppm and ppb, and also the weight percentage and volume percentage, and we explained about molarity also. Today we will explain molarity and based on the problems, molarity and the problem which are based on the molarity. So already we explained about molarity. What is the molarity? We explained molarity. We know molarity means the number of moles of solute, the number of moles of solute dissolved in 1 liter of solution. Molarity defined as the number of moles of solute dissolved in 1 liter of solution. Already yesterday we given once I want to revise. And molarity means the number of moles of solute, the number of moles of solute dissolved in, the number of moles of solute dissolved in 1 liter of solution. That we call as molarity. We know the number of moles of solute dissolved in 1 liter of solution. 1 liter of solution. So that here we have molarity is equal to molarity capital M is equal to molarity is equal to here number of moles of solute, number of moles of solute, number of moles of solute by number of moles of solute by volume of solution, volume of solution. This is so that yesterday we explained up to this, the number of moles of solute which dissolved in 1 liter of solution is called as molarity. So that molarity is equal to number of moles of solute by volume of solution, and here the number of moles taken as n by volume of solution B, that will be in liters, that will be in the liters. Suppose if we want in the, here we have all liters, the same form to represent the number of moles by volume. If it is in ml, it is ml into 1000 we have. And yesterday we explained about how to calculate number of moles, so that here the number of moles we can calculate it. The number of moles is equal to weight of given atom, yesterday given weight of given atom by gram atomic weight, weight of given atom by gram atomic weight. It is for atoms, that is for atoms. Already yesterday explained, that is for atoms. So that the number of moles equal to weight of given atom by gram atomic weight, and weight of given substance, weight of given substance by gram molecular weight of the substance, gram molecular weight of the substance. This is for generally for the molecules, and here we are given volume by volume at STP, nothing but 24.22.4 liters. That is for gases. That is for generally we are for gases, and given number of particles, given number of particles by Avogadro's number of particles, Avogadro's number of particles, those are nothing but 6.023 into 10 power 20 up to we explained yesterday. So that the molarity is nothing but the number of moles of solute dissolved in 1 liter of solution. So molarity is equal to number of moles of solute by volume of solution. If it laid there n by v liters, suppose number of moles volume into 1000 in ml. And how we are going to calculate number of moles? How we are going to calculate number of moles? The number of moles per atoms nothing but the weight of given atom by gram atomic weight, and it is also depend upon stoichiometry, and the weight of given substance by gram molecular weight of substance, and given volume by volume at STP, and given number of particles by Avogadro's number of particles, which we have 6.023 10 power 23. It is a method to calculate number of moles. If you know the number of moles, the number of moles is divided by volume, is nothing but molarity. That we have molarity. So the molarity is equal to number of moles of solute by volume of solution. The nothing but here we have the number of moles, suppose taken as weight by gram molecular weight. So that the weight of the solute by and gram molecular weight of solute into 1 by volume, and it is ml, 1 by volume of solution, ml, that should be into 1000. So that the number of moles of solute by volume solution, and the number of moles taken as weight of solute by gram molecular weight of solute into 1 by volume of solution in ml into 1000. We know the weight of solute taken as W1. The weight of solute taken as W1. The gram molecular weight of solute taken as M1. Suppose M1 into 1 by the volume of solution taken as V. If it is in ml, so that should be into 1000. It is the formula for the molarity. So that the molarity is equal to number of moles of solute by volume of solution. The number of moles we can calculate weight of solute by gram molecular weight of solutes, but it is not only formula to calculate number of moles. There are so many formulas, and based on given data we have to use the formula for the number of moles. So that finally the molarity is equal to weight of the solute by gram molecular weight of solute into 1 by V volume of solution into 1000. And some other formula regarding to molarity. So that whatever formula we want regarding molarity, all the formulas we can derive only from the formula number of moles of solute by volume of solution. Once again, whatever formula if we want, all the formulas we can derive by using only the standard formula number of moles of solute by volume of solution. The same formula for the molarity, one more formula we have. Number of millimoles of solute. Number of millimoles of solute by volume of solution in ml. This is also one more form directly. So that number of millimoles of solute by volume of solution in ml. Suppose the volume is given in ml, milliliters. The number of moles also they given as millimoles. Milli means 10 power minus 3. So that number of millimoles of solute by volume of solution. Because here we have, suppose we have millimoles means 10 power minus 3 moles. And here remember that the number of millimoles means 10 power minus 3 moles. 10 power minus 3 moles by volume of solution in ml. That we multiply by 1000. So 10 power minus 3 into 1000 will be cancelled. So that number of moles of solute by volume solution. Once again, number of millimoles. Milli means 10 power minus 3. Milli means 10 power minus 3. 10 power minus 3 by volume solution ml. So that is multiplied by 1000. 10 power minus 3 into 1000 we have only number of moles. So the number of moles by number of moles solute by volume solution. So from the number of moles of solute by volume solution you can derive one more formula that nothing but number of millimoles of solute by volume of solution. So that by using the formula number of millimoles of solute by volume solution we can calculate molarity. That is one more important formula. And according to one other formula, here we are, and here mass to volume percentage, mass to volume percentage, mass to volume percentage, mass to volume percentage into 10, mass to volume percentage, mass to volume percentage into 10 by mass to volume percentage into 10 by here molecular gram molecular weight of solute, so that here mass to volume percentage into 10 by gram molecular weight of solute, Suppose you can take this is how we got it. The mass to volume percentage means weight of solute W1 by volume will be V in ml, V will be ml, so that nothing but here we have 100, it nothing but so mass to volume percentage, the mass nothing but W1, the volume taken as 100 ml, so V ml, and into 10 by gram molecule weight of solute nothing but M1 we have. So that W1 by M1 nothing but number of moles. So number of moles to volume into 1000 in the MS we have. So that the number of moles solute by volume solution we can written as mass to volume percentage into 10 by gram molecule weight of solute. So it is one more formula for calculating molarity. So the molarity we can calculate by using the formula mass to volume percentage into 10 by gram molecule weight of solute. So that the mass to volume percentage but V by W1 by V into 100 and into 10 by gram molecular weight of the solute. So the W1 by M1 is the number of moles. So number of moles to volume we have. It is one more formula to calculate molarity. And take one more other formula. It is nothing but here weight percentage means weight by weight. Weight percentage means weight by weight into 10. So the weight percentage weight by weight into 10 and density of solution by here we have gram molecular weight of solute. Suppose if you take as the weight percentage W by W, the weight percentage into 10. Here we have density of solution by we have the gram molecule weight of solute. It is one more important formula. So the weight percentage is X, and here we have the 10, density we have the D by gram molecule weight nothing but M1. So that here X into 10 into D by the molecular gram molecule weight of solute. It is one of the very important formula for calculating molarity. That is data which is in terms of density, and weight percentage. So that here we have weight by weight. See that once again how we got it. Suppose the weight percentage means weight of solute by weight of solution into 100 and we have into 10 and we have the density And here by gram molecule of solute, gram molecule of solute W1, suppose W1, this is. So that remember that here W1 is nothing but weight of solute and M1 is gram molecule of solute and 100 into 10 to the 1000 and we have a density and here means W is the mass of solution. You remember that volume is equal to mass by density. Volume is equal to mass by density. Volume is equal to mass by density. So that in the place of volume we can take it as W by D. Here the volume term is denominator. So that that should be the numerator. Numerator is the density and denominator we have the W. So that here is the D is nothing but density of solution. D is nothing but density of solution and W nothing but your mass of solution. So that we have here D nothing but density of solution. Density of solution. D is nothing but density of solution. Where W is nothing but mass of solution. Mass of solution. So that we have nothing but D by W nothing but 1 by V. D by W nothing but 1 by V. So that there is one more formula. So molarity we calculate using the weight percentage and into 10 into density of solution by gram molecular weight of solute. Means W1 by W into 100 into 10 into D by gram molecular weight of solute. So that it is the one more important formula for calculating molarity. And next we have very important formula for this. Nothing but strength of solution. Strength of solution by gram molecular weight of solute. Strength of solution by gram molecular weight of solute. We know that the strength of solute nothing but weight of solute by the strength of solution nothing but weight of solute by your volume of solution in liters into 1 by gram molecule weight of solute. 1 by gram molecular weight of solute. So that the weight of solute is W1, the gram molecule weight of solute is M1 into 1 by V in liters. 1 by V liters. So that nothing but number of moles per volume. So that there we have different formulae to calculate molarity. That nothing but number of moles solute by volume of solution, or the strength of solution by gram molecule weight of solute. So that once I will give all the formulas, I will write on the board once again. Please be focused on this because the problem based on this only. So that the different formulae for calculating molarity, nothing but number of moles of solute by volume of solution, nothing but here N by V, suppose it is ml into 1000, that is one more formula. And some other formula nothing but mass to volume percentage into 10, by here gram molecular weight of solute. It is one more formula. And we have weight percentage means weight by weight percentage into 10 into density of solution by here gram molecular weight of solute. And one more formula we have strength of solution by here gram molecular weight of solute. So these are the different formulae to calculate molarity, and please focus on the different formulae because and based on given data we have to use the selective formula and we can solve the problems. And coming to the, what are the units of the molarity? What are the units of the molarity? Units of molarity. Here number of moles of solute dissolved in 1 liter of solution. So that here mole late inverse are number of mole per decimeter cube. So that here mole per liter, otherwise mole per decimeter cube. Here see that we know that here 1 centimeter cube is nothing but 1 ml. 1 centimeter cube is nothing but 1 ml. So that here 1 liter is equal to 1000 ml. 1 liter is equal to 1000 ml, we know. So that 1 liter is equal to 1000 centimeter cube. 1000 centimeter cube, yeah. Remember that. So that 1 centimeter cube stands is nothing but 1 ml. Where 1 liter is equal to 1000 milliliters, means 1000 into 1 milliliter nothing but 1 centimeter cube. Here coming to the 1 centimeter is equal to 0.01. So 1 centimeter cube equal to 0.01 meter we have. So that we want 1 centimeter cube is equal to here 0.01 whole cube and meter cube. So that substitute there. Here nothing but here 1 liter is equal to 1000 centimeter cube. Where we have 1000 into 1 centimeter cube is nothing but here 0.01 whole cube and meter cube. So that we have 1000 into 10 power minus 6 meter cube, means here we have 10 power minus 6 meter cube. So 1 liter is equal to 10 power minus 3 meter cube. So that 1 meter cube is equal to 1000 liters. We know very well from the units and dimensions. So that we are focusing on the units of the molarity. The units will be calculated by using the mole per liter or mole per decimeter cube. How we got decimeter cube, we are going to explain now. So that here 1 centimeter cube is equal to 1 ml, 1 liter is equal to 1000 ml, where we are 1 ml into 1 centimeter cube. So that 1000 centimeter cube. And remember that 1 centimeter is equal to 0.01 meter. So 100 of meter. So 1 centimeter cube is equal to 0.01 whole cube into meter cube. So that here 1 liter equal to 1000 centimeter cube. 1000 into 0.01 whole cube into meter cube. So the 1000 into 10 power minus 6 meter cube. And so that 1 liter equal to 10 power minus 3 meter cube. Finally, 1 meter cube is equal to 1000 liters. 1 meter cube equal to 1000 liters. 1 meter cube is equal to 1000 liters. And remember that here 1 decimeter is nothing but 0.1 meter. 1 decimeter 0.1. So 1 decimeter is equal to 0.1 meter. So that 1 decimeter cube is equal to 0.1 whole cube and meter cube. So that we have 1 decimeter cube equal to 10 power minus 3 meter cube, where we have 1 meter cube is equal to 1000 decimeter cube. So that 1 meter cube equal to 1000 decimeter cube, that is equal to 1000 ml. 1000, that is nothing but 1000 liters. So that we have 1 decimeter equal to 0.1 meter. 1 decimeter cube is equal to 0.1 whole cube into meter cube. So 10 power minus 3 meter cube. From that 1 meter cube is equal to 1000 decimeter cube. So that and also according to this equation 1 meter cube is equal to 1000 liters. So that means finally 1000 decimeter cube is equal to 1000 liters. So that here 1 decimeter cube is equal to 1 liter. 1 decimeter cube is equal to 1 liter. So that in the place of liter, we can replace decimeter cube. We can produce decimeter cube. So that the units for the molarity is nothing but mole rate inverse. Mole rate inverse or mole per decimeter cube. Mole per decimeter cube. It is very important information because according to given units, have to calculate the molarity. Have to calculate the molarity based on the given units. Here, effect of temperature. Effect of temperature on molarity. Effect of temperature on molarity. So that by increasing the temperature, the molarity will decrease because the volume is inversely proportional to the molarity. So that molarity is decreases. Molarity decreases with increasing temperature. Increasing temperature. So the molarity is decreases with increasing temperature. Why? Because the molarity is equal to number of mole per volume. Number of mole per volume. The volume is inversely proportional to the molarity is inversely proportional to volume. Where volume is directly proportional to temperature. Where volume is directly proportional to temperature. So that the molarity is decreases with increased temperature. So that molarity is inversely proportional to the temperature. Inversely proportional to the temperature. So molarity is inversely proportional to the temperature. So that there is effect temperature on the molarity. When molarity increases, the temperature will be increases. Because the molarity is inversely proportional to volume. Generally the volume is directly proportional to temperature. So that by this equation, the molarity is inversely proportional to the temperature. By increasing temperature, the molarity will be decreased. And coming to dilution. When the solution is x times diluted. When solution is x times diluted, then molarity is also decreases. Molarity also decreases by x times. So that by diluting, the concentration will be decreases. Because when the volume increases, you have to think about number of mole, molarity is equal to number of mole volume. When the volume increases, the molarity will be decreased. So that when the solution is x times diluted, that means the molarity will be decreased by x times. Suppose 10 times increases the dilution, so that 10 times molarity will be decreased. It is one of the very important factor. So that whenever the solution is diluted x times, the molarity also decreases by x times, because the molarity is inversely proportional to the volume. Where volume is increased, means diluted, so the concentration like molarity will be decreased. So where we have more volume, that is less concentration, means less molarity. So that when the solution is x times diluted, then the molarity is also decreased by x times. Next we have law of dilution. The law of dilution. Generally, the molarity is equal to number of mole per volume. So that here m into b is equal to n, number of moles. M into b is equal to, see, m nothing but molarity, n nothing but number of moles, b nothing but volume. M is equal to constant. So where we have number of moles constant, nothing but m1 v1 is equal to m2 v2. m1 v1 is equal to m2 v2. Where n is constant. So that nothing but before dilution this is, and it will be after dilution. So the first one is the before dilution, the second one is, so that here is equal to number of mole per volume, and there we have m is equal to n, and there number of moles will be constant, nothing but m1 v1 is equal to m2 v2. m1 v1 is equal to m2 v2. The m1 v1 nothing but before dilution, m2 v2 nothing but after dilution. Means m1 initial molarity and v1 initial volume, and m2 the final molarity, and v2 nothing but final volume here. And including the n, suppose we have the molarity is equal to n by v. If you want molarity m1, nothing but n1 by v1. If you take the molarity m2, nothing but n2 by v2. So it is the first equation. Suppose second equation, from 1 and 2 equation, first and second equation, we have nothing but m1 v1 by n1 is equal to m1 v1 is equal to m2 v2 by n2. So these are the law of dilution. The law of dilution is equal to m1 v1 is equal to m2 v2, where the number of moles keep constant. Suppose we have number of moles present, the dilution law is nothing but m1 v1 by n1 is equal to m2 v2 by n2. These are two important formulae for calculating the problems, and based on this we will discuss problems later. Next, one more important formula regarding molarity, nothing but molarity of mixing. Molarity of mixing. Suppose we take 3 to 4 compounds which are the same solute and same solvent. Then how we are going to calculate the molarity? So the molarity of the mixing we have. Let me take as 3 samples of solutions. That we take as 3 samples of solution. Which is the same solute, same solute and solvent. So that we take as 3 samples of solution which have same solute and same solvent we have, and their molarities are m1, m2, m3, and volumes are v1, v2, v3 respectively. Suppose we have to see. So we are discussing the molarity of mixing. Let me take as 3 samples of solution having same solute and solvent. Means here don't change the solute and solvent, and their molarity is taken as m1, m2, m3, and volumes taken as v1, v2, v3 respectively. Then and the resultant molarity of an MR, resultant molarity MR is equal to, generally we have M1 V1 plus M2 V2 plus M3 V3 by V1 plus V2 plus V3. Otherwise the resultant molarity MR is equal to The result molarity MR is equal to M1 and M2 M1 V1 plus M2 V2 plus M3 V3 by total volume or final volume, total volume. So that it is the molarity mixing. Like we take 3 sample solution which have same solute and solvent, and the molarity is M1 V1 M2 V3 M1 M2 and M3, and the volumes are V1 V2 V3 respectively. Then we are going to calculate the resultant molarity MR is equal to M1 V1 plus M2 V2 plus M3 V3 by V1 plus V2 plus V3. So that otherwise here we have total volume. These two formulas will be different, we have remember that. And whatever the total volume, have to take it. Not only V1 plus V2 V3, we will discuss the problems later, we can understand later. So that here M1 V1 plus M2 V2 plus M3 V3 by V1 plus V2 plus V3, if they given only 3 volumes. Otherwise, and M1 V1 plus M2 V2 plus M3 V3, if they given the volume which is more than V1 plus V2 plus V3, then we calculate the total volume. The volume which is more than V1 plus V2 plus V3, that total volume have to be taken here. So that MR is equal to M1 V1 plus M2 V2 plus M3 V3 by total volume. So it is the molarity of mixing. These are the different formulae for calculating molarity, and today we will discuss some simple problems to understand the concept of molarity, and one by one we will discuss the IIT JEE problems also. So that we are going to discuss some simple problems to understand the concept of molarity. Here we are discussing simple problems and based on the molarity of. So why we are discussing those simple problems means because we can understand the concept of molarity very easily. Here simple problem number 1 is the molarity of solution. The molarity of a solution. The molarity of solution containing the molarity of solution containing 5.3 grams of 5.3 grams of anhydrous sodium carbonate, Na2CO3 per liter is. This is very simple problem. So that the molarity of solution containing 5.3 grams of anhydrous means which have no water. That anhydrous Na2CO3 per liter is. So that here we want molarity capital M is equal to here according to this formula number of moles of solute by number of moles solute by volume of solution in liters. The number of moles solute we can take as weight of solute W1 by gram molecule weight of solute of M1, weight of solute W1 by gram molecule weight of solute is M1 into 1 by volume in liters. So that here remember that the weight of solute is nothing but 5.3 grams, 5.3 by here Na2CO3 gram molecule weight. Here we have 2 NAs and 1 carbon and 3 oxygens. If you calculate, here 2 into 23 plus 12 plus 3 into 60, so that we have 106. So that the gram molecule weight of Na2CO3 is 106. Here we have 106. 106 into here 1 by 1 liter, 1 by 1 liters. So that 5.3 by 5.3 by 106, 5.3 by 106 we have. So that we have the 5.3 is 1 by 20. 1 by 20. So 1 by 20 means 0.5 molar. 0.05 molar. Otherwise 0.05 mole latent words. 0.05 mole latent words. So that the simple problems, the molarity of solutes containing 5.3 grams of anhydrous NaCO3 per liter is. So that here the volume is given as 1 liter per liter. And anhydrous means that has no water, so that the molarity is equal to number of moles of solute by volume solution in liters. The number of moles solute we can calculate using the weight of solute by gram mole weight of solute into 1 by V in liters. So that the 5.3 the weight of solute by the gram mole weight of NaCO3 is 106. So 5.3 by 106 into 1. So 1 by 20. 1 by 20 is 0.05 molar. Or 0.05 mole latent words. This is the problem. And take one more problem. The molarity of 0.006 mole 0.006 mole of NaCl sodium chloride of NaCl in 1000 ml of solution, in 100 ml of solution, in 100 ml of solution is. So that the molarity of 0.006 mole of NaCl in 100 ml of solution, So that very simple problem, m is equal to number of moles of solute, number of moles of solute by number of moles of solute by volume of solution, in ml into V of 1000. So that the number of moles solute is given as 0.006. The number of moles solute given as 0.006 by the volume of solution. The volume of solution is about 100. The volume solution is 100 and into V of 1000. So 2 zeros will cancel and we have the 0.06 capital molar. Otherwise 0.06 mole latent words. These are very simple problems, and by doing all these problems you can understand the concept of molarity easily. Later you can do some difficult problem which will give in the IIT JEE mains. Next we have one more problem. The molarity of glucose, the molarity of glucose which contains 18 grams, which contains 18 grams per liter is. 18 grams per liter is. So that the molarity of glucose which contains 18 grams per liter is. So that here the molarity we are going to calculate, the glucose compound is given that we have 18 grams and only per liter we have per liter. Here remember that molarity is equal to capital M is equal to number of moles N by volume in liters. Volume in liters. So that number of moles is equal to weight of solute by gram molecule of solute into 1 by V in liters. 1 by V in liters. So we are not representing in the 1000 V, that should be the liters. Here the weight of solute W1 is equal to 18 grams. 18 grams here. W1 is equal to 18 grams weight of solute. And here glucose formula C6H12O6. C6H12O6. The molecular mass of the C6H12O6 glucose, nothing but 6 into carbon plus 12 into hydrogen plus 6 into 60. 6 into 60 we have. So that here 16 to oxygen we have. Here 6 into 12 carbon and 12 into hydrogen 1 and 6 into plus 16 we have. So that's 72 plus 12 plus here we have 96. So finally we have 180. Finally we have 180. So that the M1, the molecular weight of solute is 180. The molecular weight of solute is 180. So simply substitute that the molarity is equal to weight is 18 grams and gram molecular weight is 180 into 1 by the volume is 1 liter. 1 by volume is 1 liter. So 18 by 180 nothing but 1 by 10. 1 by 10 nothing but 0.1 molar. 0.1 molar. Otherwise nothing but 0.1 mole rate inverse. Mole rate inverse. This is the molarity. And there we have so many problems we have. Those problems we will discuss one by one, and all the different problems we will discuss. Here see that one more is finally here 1 m nothing but molar, and here we have 0.5 m nothing but semimolar, and 0.1 molar nothing but decimolar, and 0.001 molar nothing but centimolar, and we have 0.01 molar called as millimolar. So that 1 m nothing but molar solution, and 0.5 is centimolar solution, and 0.1 molar nothing but decimolar solution, 0.01 molar nothing but centimolar solution, and 0.001 molar nothing but millimolar solution. And based on this we will do some problems by tomorrow onwards, and the math problems we will do based on the molarity later. Thank you.
48 minutes.